So here's the bridge. Up the top you'll see a number of dials. Let's start working through each one of these one by one. That one you don't need to know, that's time. That is underkeel clearance, log speed, so that's water passing underneath us. As you notice, when you come up the stairs from here, that will be one of the first things you see. That is a more accurately calibrated one for use in science, so most ships won't have that. Your clinometer tells you how far you're heeled over or listed over to each side. Your rudder angle, as you see there, we have two rudders. On this particular ship, we have two Becker rudders, or high lift rudders as they're also known, so they have an additional flap on the end. That's our wind speed, and sensor, and you can see there, it's clearly from the starboard side, and that is our gyro heading. Now, let's start looking at all of these things in front of us here. There are a number of screens there, and you see that they are all similar. It's part of an integrated bridge system. This particular one is a Kongsberg system. If we start over here, this gives us an ECTA screen. So electronic chart and information display system. So as you can see straight away, that is our charts and our current location. And it will also give us a number of sensor inputs. So here, that is our accurate position, and that tells us that is a DGPS, so that's differential global positioning system from our first satellite. And that is a differential position, so that means it is more accurate than a undifferentiated position. So our sounding depth, our log speed, as we've just discussed, that's speed through the water. Speed over ground, as you can see, we're currently moored. That's our heading, and that is our course over ground according to GPS 1. I should draw your attention to the fact that there are a lot of different manufacturers out there, and they do not look all the same, so you need to be aware of the different types and familiar with the system that you are using. As I alluded to before, it's an integrated system, so these do talk to each other, and there is a certain amount of flexibility with that. So if we click up here, we're currently on the active screen, but I can change that to a radar screen, for example, and you can also change that to a conning screen. Again, this will be dependent on the system that you are using. I will walk through those other screens shortly. So we'll just come over here to our radar screen. First thing you'll probably notice with this one is you're probably wondering why the screen is square. That is simply a manufacturer's choice. Many manufacturers do not use the square format, so you will see the circular standard type. What is common between different manufacturers is here. You'll see your range or your scale and your head up, north up or course up. In normal operation at deep sea, we will be using north up, relative motion, true motion, ground stabilized and water stabilized. Each one of those things, let's go through that one by one. So north up, north is at the top. Head up, that is where the ship's heading. It's always going to be at the top of the screen. You may find that pilots will use that coming into pilotage, for example, down the river. It allows them to be able to look at something on the screen, look out the window and be able to relate it to something fairly easily. The main reason that we chose to use north up most of the time is that we can see here, and when we look over to our chart, these two things will marry up. It's nice and easy. Some of it's choice, but generally I tend to use north up. Our course up is our course over ground. Simple. Of course that's stabilized. Or should I say that takes an input from our course over the ground, which it takes from this one, from GPS 1. Again, because I alluded to this being an integrated system, it allows us to see these targets here. So these targets are AIS targets and are not part of the radar or ARPA standard. So on some systems, that is not something that you would see. You can turn that off here. So the radar is currently not transmitting. So as you can see, there are no targets on the screen. On this particular system, they appear as yellow dots. We can then select them on this particular system using the acquire button. It takes up to 3 minutes to get an accurate track on that. We can click data, and that will give us some information here. Since this isn't transmitting now, we won't be able to do that. Here, again, this is set up some personal choice. We tend to always have vectors on. The biggest choice for the mariner would be whether it's relative or true. As you may have noticed, if I take a step back, you'll see that we do have 2 radars. What we tend to do on here is that we'll have one set to relative motion and one set to true. Why does that matter? Relative tells us how you see a line and it's heading straight towards you from the vector of the vessel. That's its projected time on this particular setup in 12 minutes. If that is aiming straight towards the center of the screen, your ship, you should be very worried. Conversely, if it's set up in true, that may appear slightly differently. It would appear to go perhaps in that direction as opposed to that direction. So whenever you're looking at a radar screen and making an appraisal of the situation, you need to be aware of how your radar is set up. We'll go back here to ground and water stabilized. Again, we should talk about why that matters. Ground stabilized, we'll go into that. That will be useful for taking a range and bearing, for example, to get a position fix when you're in coastal navigation. However, if you're doing collision avoidance, you will want to be doing it in water tracked. The theory being that the log input is taken into account and the water on the surface is all moving generally in the same way, and that will that allows us to work out to give us a better indication of collision avoidance situations. Setup on here, you generally want to start on the highest, bring it down until you see just a few speckles. Obviously we don't have this transmitting now, so we're not able to demonstrate that. Sea clutter, we'll get rid of the clutter in the center of the screen, and radar clutter will get rid of it further out on the screen. Now, being aware of what these actually do, that may, if used incorrectly, remove a target from the screen. So you want to use them, yes, but be aware that they may remove targets, so it's generally advisable to use as little as possible to get a clear screen. Electronic range bearing, so electronic bearing lines and variable range markers. Down here, again, it will be different in different manufacturers, but that allows us to quickly get, so you can click here, the distance and the range of the target you've selected. We'll move over here to the conning screw. Now this is very specific to this ship. You may not see that on any others, but what it does allow us to do is to see how much load are on our main engines. And on this particular ship, it is a dynamic positioning ship, which also has a forward thruster, a retractable azimuth thruster, 2 stern thrusters, and of course have 2 rudders. This is also giving us more information about wind here, relative and true, depth, and again that is giving us wind in relation to an outline of the ship, and it can also give us an indication there of drift. Of course we're stationary at the moment, so that's not giving us much information. Basic things here, telegraphs. Telegraphs will tell us, we'll be able to change the engine order and the speed. So simply more on, faster. Astern, astern. Now these are emergency, which will be part of the tests. You'll find that on any ship. Be aware here that this has a bridge navigational watchkeeping alarm system, so that this will go off and alert the captain after 12 minutes if there has been no activity. You can also press this button here to alert the captain directly. Steering gear pumps here. We have 4, that's 2 for each side. Normal operation be only 1 for each side. When we're in pilotage, then we may use 4. Here, similar setup to there, so I won't go through that again. This is a AIS screen here. As I alluded to, this is an integrated system, so we can actually interrogate our AIS system through this. Again, depending on your manufacturer, so be aware of how that operates. What I will do is show you on this screen how that works on this code bridge integrated system. Targets, AIS, set static voyage data. Why that matters is our navigational status. So if I go over to this screen here and interrogate this target, it tells me name of the vessel, its bearing, range, CPA, closest point of approach, that is, time to closest point of approach, speed over ground, etc. When I should go down here, so that's perhaps not a great example. Let's take another one here. Those are all leisure craft. But they will show us this navigational status. Of course, ours is currently set to moored. Let's have a look at the few other options you've got there. Underway using engine, at anchor, not under command, restricted manoeuvrability, etc. VHS currently not on. Fairly standard set. Again, be familiar with the one you have on board. This is a screen for a voyage data recorder for recording the sensors, and it's also had microphones up here of what's going on. Essentially, a ship's black box. This is an integrated system here for engines and power. It also has ballast. Have a look at there. It gives us a few different options. Again, this will vary depending on the vessel you're on.